Please welcome Fabian Prasser, Charité Universitätsmedizin Berlin and Berlin Institute of Health. Beyond anonymization, innovative approaches to safe health data sharing.
Okay, thank you very much. The use of methods of health data sciences, including machine learning, promises to enable precision medicine, to prevent errors, and to reduce costs. However, to develop such methods on a broad scale and to use them, we need really huge data sets. Data sets need to be huge in the sense that we need complete health records of individuals containing many different types of data that are typically stored in different isolated silos. Data also needs to be huge in the sense, however, that we need data from many different individuals that are, again, typically stored in different isolated silos. So bringing these different types of data sets together poses challenges from a legal and data protection perspective. A recent suggestion that has been made is that people might be able to donate their data to medical research, and there are polls showing that, for example, 75% of the German population would be willing to do so. However, if we take a closer look at these polls, we see that the question that is typically asked is whether people would be willing to donate their data in an anonymous form. And this is actually challenging from a technical perspective, so how can we do that? To enable anonymous data processing, we can and often must address multiple different levels. We need to make sure that data use is appropriate, that people working with the data are trustworthy. We might need to apply data minimization principles to input and output data, but we can also use methods to create safe settings that make sure that no sensitive data is leaked during processing. So how can we do that? One way to create safe settings is by using distributed computing technologies. In the most simplest form, we take our analysis, distribute it to the data silos, collect the results from those silos, apply some additional safeguards, combine the results, and come up with a global result or a global result to our analysis. Now, what I wanted to highlight with this talk is that this is not just a scientific playground, but that these methods are used on a broad scale in production today. My first example is the ACT network from the United States, which is a distributed network supporting the accrual to clinical trials. My second example is from the German Medical Informatics Initiative, where we have performed a demonstrator study using a distributed data processing pipeline to perform a meta-analysis of locally aggregated data. My third example is the Odyssey network, which uses a common data model to enable quite a variety of complex distributed data analysis. Now, finally, I would like to highlight that there are lots of ongoing projects that aim to roll out these solutions. There's the Eden project, which aims to roll out Odyssey across Europe. Within the Medical Informatics Initiative, there will be a use case on rare diseases using these types of techniques. And in parallel, there are further applications being developed, for example, to use these techniques on a large scale over the mobile phones of millions of people. Thank you very much for your attention.